All right. Good afternoon, good morning, good evening, everyone. Thanks for taking the time to join us. I still see some few people flowing in here. That's great. Really glad to have all of you here with us again for an ICMS mentoring networking session. We're going to be talking to Tom Gideon today. I'll talk a little bit about what he's up to in a little bit. But before we start, I just wanted to say welcome, and I wanted to turn it over to our executive director, Tom Weisenbach, to say a couple things and encourage you to become an ICMS member if you're not already.
Dr. Ferguson, thank you. And again, Tom Gideon, great to see you. Thanks for joining us today. Appreciate everybody jumping on with us today for our mentor program. I'm really excited about what David's been able to accomplish with this so far on behalf of the ICMS. When we really started talking about this concept of a mentor program, what could it be? How would we use it? Obviously, we want to use it as a recruitment tool for membership and to get more people engaged with the ICMS, especially younger folks who are still in school with hopefully maybe having a career pathway that leads them into motorsports, medicine, fire, rescue, safety. So again, it's great to see that in about 2 years we've been doing this, we've added 22 students as members, as well as several other folks such as David in the educational academia world to the ICMS. So we appreciate that very much. And again, we've got some other great programs throughout the year that we'd love to have you take advantage of and join us for. So again, David, thanks for the opportunity.
Thank you, Tom. I appreciate you. So that's kind of the theme of this. We have these once a month meetings to kind of learn from experts in the field of various aspects of motorsport, health, human performance, safety. I do want to kind of just make a quick update, kind of a plug. So this is we're calling this season 2 of what we're doing this year. We're going to do something a little different. So in about September and October, we're actually going to have all of you speak if you'd like to. So we've brought in experts to chat, share career paths and everything, but we know that there are some students, some trainees that are also working on great motorsport projects. I myself can think of one student that's working on one project that I think is truly phenomenal and truly amazing, and they should be sharing this stuff. So what we're going to do is, if you have a project, it can be anything you're kind of working on, anything you're developing related to kind of the human element in motorsports, we'd love to hear about it. So in September and October sessions, if you're interested, come talk to us for 12 minutes. We're going to invite back all of our previous speakers, and they'll sit there and give you feedback. It will not be critical. It will not be mean. It'll be welcoming. It'll be warm. I promise. But, we're all here for you, and we'd love to hear all the great things you're working on. So if you're working on something, and if you're interested in doing that, please send me an email by kind of the middle of June, and just kind of tell me what you're working on. We'll start pulling this together. So kind of just a little kind of tips and things like that. It'd be great to get a little information. I'll send some more emails out about that as we get closer. But today we're actually here to listen to Tom Gideon. And so I've known Tom for several years through ICMS. When you think of motorsports, if you work in it long enough, you have a chance to meet some legends, and it's truly inspiring to meet them. What's even better is when you meet a legend that's also a really nice person and very caring and very welcoming. And that's Tom. I remember the first time I met Tom, he was great. He was welcoming. It was kind of my first ICMS. He wanted to see me get involved. And then, as time went on, I realized that a lot of the things that, help keep drivers safe and alive, Tom had his hands on. It's truly impressive to see what he's done, even if he did go to Ohio State, and that's okay. That was my one comment about it, Tom. Thank you so much for taking the time to come talk to us and share this. Tom is a very humble individual, and you're going to see in this presentation, he's worked on some pretty major topics. And I know Tom's not going to toot his own horn. So if you want to learn a little bit more, if you have questions, please ask him. I know he's going to be happy to chat with you. So Tom, thank you so much. The floor is yours.
Thank you, David. Appreciate it. I appreciate everything ICMS does. That first slide, if everyone can see, are we sharing properly, David? My contact information is on there. I welcome anyone to call. We'll be referring to some publications today. I'll send you anything that I've had anything to do with. My background, the Ohio State University, a professional engineer in the state of Michigan, former manager of GM Racing Safety Program and former senior director of safety at NASCAR, a member of the SAE, and a proud member of the ICMS. Also a member of the FIA Research Working Group and a board member of the SFI Safety Foundation. The beginning. So here I am, 4 months old, and I didn't know that I'd have an engineering career. But as you can see from the photograph, it does give away my age to some degree because color photography had not quite come onto the scene yet. To get started in a racing career, here I am at age 13 with a home-built go-kart, top speed 20 miles an hour. But anyone who is involved with home-built go-karts at age 13 may become an engineer. Outline of the career, early mentors. My father was an engineer. My high school physics teacher made science interesting, and I was interested in cars. And this is a mentoring program, and so that word is going to be repeated many times today. So my interest in car, here I am at age 21, 54 Austin Healey. If anybody wants to know anything about the early Healeys, I know quite a bit. It cost $400 at the time, and that'd be $3,800 today. Cool car, spoke wheels. That windshield you see actually laid down so you could go faster. So I have questions for you. You know, what are your interests and what are your passions? Are any internships available? Who are your mentors? Who are your friends? What networks are available to you? What questions you have? And I think you need all of those to get through a career. I did not have any internships. You know, in my day in college, that would be a very rare happening. Today, I think internships are very much more the thing. And I can only tell you about my daughter, Melanie, who attended Indiana University and did her master's at U of M. But she got an internship halfway through her master's at UCLA Health. And they liked her. She did good work for them. And she knew she had a job before she did her last year at Michigan. So she took over a program called Operation Mend that restores wounded soldiers that have been burned with plastic surgery. She did that for 11 years. She now is the COO of a group called Stop Soldier Suicide in North Carolina. And you can look that up. A very valuable group. You know, there have been more than 30,000 soldiers commit suicide since 2001, which is 4 times the number that were killed in battle. Mentors like my father influenced my engineering career, and friends helped me. That's another important ingredient. I actually moved from engineering staff to Chevrolet with the help of a friend. I moved from Chevrolet to GM Racing with the help of a friend, and I moved from GM retired to NASCAR safety with the help of many friends. Networking. When I was in my early career, the networking was really a business card and a Rolodex. And today, there are so many more possibilities with LinkedIn and other social media sites where people can connect and network. And ICMS is a huge contributor to networking. And I would say that a major part of what ICMS does is to get people together in all fields and that are interested in motorsports and have them network. And that's where I do a lot of my networking. So some career highlights. I'm just going to touch on a few things I was involved with that did have something to do with safety. The Hans device was invented by Bob Hubbard, PhD at Michigan State University, also an ICMS member. And I worked on the Hans in sled testing to help develop it and show what it could do in different situations. The right side net probably is what I'm most proud of. I did some early testing on that, and you know, that is normally seen in race cars today, especially if you're not in NASCAR with a full surround seat. And then the reinforced seat, that's something else that came out of early crashes and data from early crash recorders. One other thing I'd like to mention is the importance of reporting. Whatever field you get in and whatever project you work on, it's very important to make a report. I've written a bunch of SAE papers and co-written a bunch. And as I said, you can get any of those if you want to contact me. They're on almost every aspects of putting the car together. And you want to publish your work in any respected journal related to your field. It's really important to have that as background. You may not stay in the same job your whole career, and you may need to move. And when you need to move, having those published journals in your resume is very critical. Here are three SAE papers with regard to the three safety items I mentioned before. The first is neck tension comparisons with various sled test pulses. And that was a study to see if you could save the driver by making the perfect car. And the perfect car is one that crushes in what we call a square wave type of crush. The second is race car nets, and that's the right side net I mentioned. And then the race, excuse me, the race car seat design, where we did everything we could to improve the structure of the seat. So here's a little bit of how the Hans works. You can see here the Hans device with tethers connected to the helmet. And on the right, you can see no Hans device. And you see the little vectors there. And in a forward crash situation, what you really worry about is the neck tension. And the failure mechanism on what happens with what we call a basilar skull fracture. The torso is restrained by the lap and shoulder belts, but the head pitches forward, and the centrifugal force caused by the weight of the head, and that's, you know, anywhere from, with a helmet on, is probably 15 pounds. That centrifugal force, as when you reach 4,000 newtons or 900 pounds of force, you'll probably get a basilar skull fracture, or you might have a separation at C1. And when I refer to this medical things, I'm the engineer, so I have no background in these things, but I do have background in crash test dummies and the forces that happen. So here's a particular, this is the neck tension comparisons with the various sled pulses. And this will be interesting. I think it's probably hard to see here, but this sled pulse, the green sled pulse, if you can see it, is actually what was calculated from the Earnhardt wreck. It peaked at 47 Gs and it had a triangular shape. And the suggestion was, well, the cars are too stiff, and if you could give it a square wave pulse, then the driver would probably survive. Well, at Delphi, they had the ability to take all these pulses, and these pulses all had the same change in velocity, which is really the parameter that determines the energy in the crash. So by running all these tests with and without a Hans device, you could see if the dummy would actually survive with a square wave pulse. And I won't go into the details here or the numbers, but the answer was probably not. He did a little better with a square wave pulse, but when you put the Hans device on, it didn't matter what pulse you gave the car, the neck tensions were low and survivable. So the right side net development, the Hans device is good in a forward crash situation where you see the blue area here, 45 degrees left to 45 degrees right. If you have a side impact, the Hans device will not keep you from getting a basilar skull fracture. And that has been seen in many crashes. We can go back, I think the last one was at Le Mans, and that was a side impact, and that driver died of a basilar skull fracture. So what you do then, and this is what we ran, and of course we ran a bunch of tests to determine this, because the geometry is very critical. You want to pick up the shoulder and you want to pick up the head, and if you can do that, you limit the motion of the head, and by limiting that motion, you keep the neck tension low. Here I am at Sebring in 2003. That's the first time we put those nets in the Corvettes. That's Oliver Gavin driving. And you can see here, we're picking up the shoulder, we're picking up the head. And the drivers, normally when you put things in a driver's compartment, they sometimes resist the change. But we had run tests at Wayne State with dummies that were dressed up like drivers in driver suits and with helmets. And when I showed them the difference between having a net and not having a net and showing them the data, they said, put it in. So we did. And the Corvette actually won their class at Sebring that year. So reinforced driver seats. This is research done in Indy cars and crash recording that was started by John Melvin and John Pierce at GM Racing in 1993. The first application of crash recorders in racing. And that research led to a reinforced seat design because of what was learned in IndyCar design. And that's the report on that. And I co-wrote that report with John Melvin. And you'll see here with that sketch why this is so important. These are some of the accidents that were recorded in IndyCar. And the y-axis is the G load at impact. And you can see there are many, many wrecks here, but there are many over 80 Gs here at the end. And all these drivers survived. And the reason they survived is because their seating position and the way the seat surrounds them, especially giving them support in the pelvis, shoulder, and head area, is the reason the drivers survive. The key in these crashes is to not have any body movement. Any movement of the body, the G load on the body actually is higher than the G load on the car because you have a slide hammer effect where you impact. So what we did is just take all those principles and put them into the stock car seat. And we talked about the right side net, but by extending the head support in NASCAR, you can do the same thing as the right side net. It limits the movement in a side impact. Here's a picture of Tony Stewart back in probably 2008 or so. By that time, reinforced seats were already in place, and you can see his view and the view of Joey Logano, and you can see that right side headrest comes quite a ways out. So those safety improvements were validated many times in NASCAR races. You know, I'm proud to say that there hasn't been a fatality in NASCAR in the main series since Dale Earnhardt died in 2001. So here I think I can run a little validation just to show you. Now, this is Michael McDowell, Texas in 2008. And he's in a qualifying lap. Many of you may have already seen this. It is available out on YouTube in several forms. You can see Michael climbs out. I'm going to run that one more time because he's hitting the safer barrier there. That portion of the safer barrier is the last time I visited the NASCAR Hall of Fame. They have that portion of safer barrier on display. I was at that race. I talked to Michael after the race. We got his helmet. They did some studies on his helmet to see where the impacts were on the helmet. But other than being a little sore, this, I believe, was on Friday. He went to his backup car and raced on Sunday. So that's just a testament to how hard wrecks and you can survive them. Michael also won the Daytona 500 in 2021. So a wreck like that doesn't end a career. So that was impact safety. I also worked on trying to improve the driver's environment. In 2001, I introduced carbon monoxide measuring devices to both Corvette team cars. The CO sampling was done by monitoring the air to the driver's helmet, and then the data was then transmitted to the pit box. In 2003, we measured the hearing on all the NHRA drivers. As you know, NHRA can make high volumes of sound, and that was very good. The drivers got to check their hearing, and the audiologist, Don Flynn, offered them protection. A lot of the drivers got form-fitting earplugs, also with radio in them, and that was good. We also did that with the Corvette team drivers. In 2007, air conditioning was added to the Corvette team cars, not because they asked for it, but it was mandated by the sanctioning body. At that time, Aston Martin had a problem with heat inside the compartment. And the openings were sized in the windows to ventilate the cockpit because they closed it off with the air conditioning, and they had to take the CO out. And of course, CO monitoring was a key to that. And air conditioning in those cars changed the whole driving environment. The drivers got out, they were in good shape. Before they'd come out, they were dehydrated. They were just like a wet sponge. And after this, they got out, they'd take off their helmets, and their hair was even dry. So, it was a big improvement. So wrapping it up, I mentioned the contribution of mentors of John Melvin and Bob Hubbard. Both were members of ICMS. I've been a member of ICMS since 1997. My career has been greatly enhanced by my years in the ICMS and again through networking. And I welcome any questions you have. Thanks.
Tom, thanks so much. That was great. I really appreciate that. I have a couple questions, but I'm going to pause and open it up to the group if there's any questions from the group.
David, I'll start the group off.
Go for it,
Tom,
Tom.
question for you. I mean, obviously through the years, with the cooperation of a lot of great folks, you brought so many new programs of enhancing, I think, the motorsport safety for GM and NASCAR. Is there a program or a initiative you tried that just didn't come to fruition? I mean, is there one that just didn't happen that you were disappointed in?
Yeah, Tom, you know, there's so much trial and error in the safety work. You know, many of the things that we looked at didn't quite work. And you have to go back and try again. When we were doing our windshield testing, you know, we had some occurrences where a brake rotor would come off and go actually into the windshield and through the windshield. And so in 2013, we reinforced the windshield, but in testing that, we tried to come up with a slug that would go through the windshields. It didn't work. We had to go back, and it's real quick because we're set up over in the NHRA parking lot, and the first projectile didn't work. So we said, let's make it twice as big. And we went back, and sure enough, the second projectile, which weighed 386 grams, if I remember, went through the baseline windshield at 200 miles an hour, and it only slowed it down to about 100 miles an hour with high speed photography. But then the laminated windshield that we used would stop that projectile. And so all the cars have got laminated windshields now, similar to your passenger cars, only of course we're using much stronger plastic, and and of course the tear-offs help too. It turns out tear-offs are very, very strong. They're made out of Mylar, and the tensile strength is huge on Mylar. So.
Chris, did I see a hand go up there?
You did. Tom, really appreciate the talk today. Thanks for taking the time. I'm curious because I work mostly with drivers. If you have any more stories about kind of your role of, did drivers ever try to say, no, this isn't going to work for me? Did they push back on anything? Or
Oh yeah.
like, can you talk through kind of how you would maybe work with them to make it a little to do the thing they need to do?
Hans device was a hard sell, especially until it was mandated. And you know, sanctioning bodies have got to mandate things. You can't recommend things. We've learned that. Though I offered, I actually supplied Hans devices for free to drivers that would take them. I tried to get Dale Earnhardt to wear one, and he just totally objected to it. Ken Schrader, when I talked to Ken Schrader about it, he went over to the workbench and he knocked on wood. And he said, you know, one of the problems with drivers, I often tell people that drivers are a lot like bank robbers. If you told a bank robber that he was going to get caught and put in prison for 20 years, he probably wouldn't do it. But there isn't a bank robber out there that thinks he's ever going to get caught. And drivers are the same. So you have veteran drivers that have been through many accidents, and that only emboldens them to think that this is not going to happen. So no, many drivers did not like that, but many drivers did accept it. And obviously after Dale Earnhardt died, It was, they couldn't make Hans, you know, their assembly plant down in Georgia was not ready for the onslaught. And then, of course, after it's mandated, it makes it simple and you move on. And many things that the sanctioning body mandates, even though the drivers would have pushed back individually, once the sanctioning body mandates, the drivers accept it even better than you think, because they know everybody's got to do it. And their job is to beat the other guy. So if you feel it's a handicap, we're all handicapped to the same degree. So that's the psychology there. But with my budget at GM, I bought a boatload of Hans devices and just gave them to people free, because at the time they were they were $1,250, and that is in 2000 money, and because they were carbon fiber, and that was kind of unique. So I think I may have helped the Hans company stay afloat before Earnhardt died, because people were not accepting them unless they were free. They often said, yeah, I'd like to get one, but you know, that's a set of tires.
Sure.
So, I mean, that's a guy that's never going to die, right?
Yeah. Perfect. Thank you so much. I appreciate it.
So Tom, actually one of my students took my question and put it in the chat. So I'm going to ask
Yeah.
it now, Tom. So this
Yeah.
comes from Abby. You know, she kind of wants to know what's coming next. What is a motorsport safety engineering advancement that you hope to see in the future? So what do you think is next? What's the one that you want to see come next?
Wow, that's a very good question. You know, it's just a continuing evolution, trying to make sure that the drivers are well restrained. You know, and I think we're in pretty good shape in places like NASCAR and IndyCar, and that's proven by the accidents that are on TV. But I think really the next advancement is to move all this stuff down to grassroots. And, you know, we've had several, you know, conversations on this, and probably several joint meetings where you need to get this stuff moved down and try to show that the expense of putting it in is more than overcome by the expense of the medical care that you need after you don't do it. So, you know, I see, you know, I see on the horizon, I see electric cars. We've talked about the safety there. And, you know, just everywhere you look, there's better ways of doing things, research, just to make things better for everyone. So that I can't predict what the next thing will be, but I think the next thing will be moving it down to the classes that run on Saturday night and keeping them alive.
Great. Thanks, Tom. And thank you, Abby, for the question. That was great. You know, I'm going to also feed you Nevin's question that was put in the chat. You know, Tom, so Tom and I actually kind of flipped through the presentation yesterday just to, you know, make sure all the technology worked. And, you know, you look at all the things Tom worked on, and it's quite impressive to work on so many of these. Some people only work on one major thing. So Nevin's question was, what do you think has been the most impactful safety feature development that you've worked on in your career?
Probably, I'd have to say the right side net, you know, only because on the Hans device and on the more rigid seat and those sort of things, I was a player, but I was not the main guy. And I ran a lot of tests and I made a lot of suggestions. But on the right side net, I really started that one. So, and I was able to convince people to do it. And once it got done, then sanctioning bodies were convinced. Grand Am finally put it in their rule book in 2009. And so And then FIA finally put it in their rule book. So I'd have to point to that as, because I felt that I had to run the tests and I had to, prove it. And the thing about the right side net, you talk about a reinforced seat in NASCAR being a lifesaver, but I ran my tests with the net with the worst seats in the world. They were flimsy aluminum, and yet with a right side net, you can still, and a Hans device just to prove it, you can still save a person because that right side net picks up the shoulder and the head and keeps what we call distraction from occurring.
Thanks, Tom. Other questions for Tom? So I have, this is another one of my questions, Tom. You mentioned talking about the basilar skull fracture, and you said you're not a physician, you're an engineer.
Right.
So my question is kind of more for the students and trainees out there that, if you're going to go into this, you're going to have to work with physicians, engineers, physiologists, psychologists, all of them. Any advice or tips on how you interacted with physicians and medical personnel in your career? Like, you clearly have made a success of it. Any tips, thoughts that you could share for the young people coming up?
Yeah, the one thing that really keeps us all together, and we've argued, and the medical people have argued with the biomechanical people, and the biomechanical people have argued with the engineers. But the great leveling thing out there is physics. And the great thing about physics is when you go back, the formulas are really pretty simple. And the mathematics, we're really talking about algebra, no differential equations, so when you look at it, you can all agree that if this happens, these forces are created, and then the forces, the medical people and the biomechanical people can tell you what those forces might mean on the human body. And really where the research is lacking, and it always has been, is, where is the human body, and unfortunately we have to find that out by running cadavers that are 75-year-old people. And that, that's not a good example of what forces take to break bones and that sort of thing. So all the engineer can do is tell them what kind of forces you're going to see, and then they can go back to whatever model they have. Now, the full body thumbs model, they're creating now a biofidelic kind of model that really will give good data, and we've seen presentations on that, and it's really starting to change the way we build things. So that's where that's going.
Thank you, Tom. I appreciate the other little gem I took from that is I need to have all my students take math and physics courses if they're going to train with me. And it's probably a good thing their cameras are turned off right now, because the faces they would give me would not be pleasant. Other questions for Tom? Tom, yes, go for it, sir.
Obviously, Tom, a challenge for any of our research that we do, motorsports safety wise, it always seems to be budget. Is there anything you feel we could be trying to do, especially in the grassroots level, that doesn't require a large budget?
Well, that's a tough one, Tom. I dealt with this before Earnhardt, and I dealt with it after Earnhardt. And it's such an unfortunate thing that somebody really has to give their life, to get changes made. There was no problem getting money after that. But you have to show why these things are needed, and then you have to work with people to convince them. And like I said, in many cases, I think you have to show that the consequences of an accident are so expensive on so many levels that it's so easy to show people that you don't need to do that. You know, I gave talks to people in sports car racing. And, you know, at one talk, the families were invited. It was a picnic kind of thing. And the drivers listened and they were interested. But I'll tell you, the wives, the wives were very interested, and they were probably the best people to convince their husbands to put something on. So, you know, the money can be made available, but you have to show why. And, you know, you just have to convince them.
Thank you. Tom, David, I got one more for Tom. So Tom, you mentioned to us earlier in the slides who your mentors were, right? Your dad and some of the others.
Right.
I know that you've been, I think, fortunate enough, or we've been fortunate enough to have you serve as a mentor to some people. You know, John Padillac down at the NASCAR R&D Center, and Tara, you know, obviously Tara Troxel,
Yeah.
you've been a mentor for really both of them. What do you, I guess, what's the biggest takeaway for you getting to be a mentor for someone now?
Well, you know, obviously you want to see them succeed in what they're doing, you know, and I guess if you look at Tara or John, they succeed. I don't know if I had anything to do with that, but I was around, and you know, I had the passion and I wanted to do it, and I think they had the passion too. And when you get people that want to do something together, it's great. You can create.
Yeah. Thank you for that. That's kind of a nice tie in there. But I was going to ask Tom about too, was kind of, you know, how do you transition out from being a mentee to a mentor? And that feeds in really nicely to what's going to happen next month. So you heard the name John Padillac. So next month, we're going to kind of continue our engineering conversation with Matt Harper and John Padillac from NASCAR. And it's going to kind of pick up where Tom left off and talk about some of the recent stuff that's happened in NASCAR in the last 8 years. So I encourage you to come see that. With that, we're getting close on time, not completely out of time yet. Is there any last minute questions, thoughts for Tom? Well, with that,
David, hey, David, I can share real quick if the group doesn't mind our upcoming ICMS events. We you know, between David's with the mentor program, our cafes, our annual Congress, our racetrack safety program, we have a lot of activities scheduled already for the remainder of the year. In April, our cafe is going to be on designing a safe rally. Ricard Johansson, who's the chief safety officer for Rally Sweden, will be leading that discussion. The cafes are very similar to what David's done here with the mentor, where we kind of have that subject matter expert come in, spend about 10, 15, 20 minutes talking a little bit about the topic, and then we open it up for discussion. So again, Ricard will be covering designing a safe rally. Rally racing is an interesting, I guess, sector of our industry. Had more people killed in rally racing last year than all other forms of motorsport combined. And what's really scary is half of those people killed at rally were spectators. So we're going to be covering how to plan for a little bit of a safer rally event. Coming up in May, I think we're going to have a unique one. I've got a good friend, Irish Saunders. His son, Eric, was injured in a motorcycle practicing on his dirt bike, and is a quadriplegic, but he actually is able to race in sprint cars, 360 sprint cars, and he does it on a regular basis. It looks like Eric's going to be able to join us to talk about not necessarily his injury, but what changes, back to the engineering side, Tom, what changes has his team had to do to his sprint car so he can drive it? And if you're not familiar with the sprint car, you know, it might be one of the biggest beasts to drive, right? Because most of the time your hands are like this as you slide through the corners. So again, that's going to be a really interesting event for us in May. That'll be on May 15th. We do have our annual Congress is already scheduled for December 11th and 12th here in Indianapolis. Plan to attend. We're going to do our racetrack safety program on Friday the 13th for Jump Medic. I'm working with PRI so we can do a fire rescue one on Saturday the 14th at their offices out in Speedway. And again, man, we just, between David and the rest of our board of directors, we're constantly trying to add events that you might see as a value. So we hope that you can join us for some of these other events. I shot the link to our upcoming events there in the chat box, so grab that and save it. Our cafes are open to anyone. Our seminar series is open to anyone. Obviously, the mentor program, we're targeted towards the folks involved on the academia side and our students. But again, I appreciate David taking us in and taking us on. As I said earlier, we have got to find a way to get more young folks involved in the ICMS, and this is proving to be a great way to do it. So thank you.
You're very welcome, Tom. Thank you for the kind words, and thank you for sharing all the great stuff that's coming up for everyone out there. As always, this will be posted online for you to view if you didn't get a chance to view it, or if you'd like to see it again. I'll simply say a big thank you to Tom Gideon for taking time to do it. I really appreciate it. And have a wonderful rest of your day, and we will see you all next month. So thanks again, everybody. Take care.
Thank you, David.
Thanks, Tom.